The protocol basics is that the master waits for a button push, and once the button is pushed, the master begins communication and sends the first byte of data, which in this case is which pin to digital write to. Then sends the second byte, which is the high or low state of the LED. In this case, it's passed as an integer instead, with 0 being low and 1 being high. Then once the data is sent, the master ends communication. The slave then digital writes using the pinout and state variables set by the master. Once the simulation starts, the master Arduino waits for either the left or right button to be pushed. After a button is pushed, the LEDs the slave Arduino is connected to begin to light up one by one until they are all lit up. Then they begin to turn off one by one until they're all turned off. The direction they do this is determined by which button is pushed. The left makes it go from left to right, while the right makes it go from right to left. The master is connected to the slave through the A4 and A5 pins that are SDA and SCL pins. Additionally, the master is connected to a breadboard through the ground and 5-volt pins. On the breadboard, there are 2 buttons with 10K resistors. Pins 9 and 10 on the master are connected to the buttons, and once pushed, they set the variables that begins the LEDs to light up. The slave is connected to a breadboard with 3 LEDs. Pin 3 connected to a green LED, pin 4 connected to a yellow LED, and pin 5 connected to a red LED. All LEDs have 200 ohm resistors, and finally the slave's ground connected to the ground of the breadboard. The wire.h library allows I2C communication through the master, enabling communication using wire.begin transmission, and sending data using wire.write, and having the slave use wire.read to receive the data, and finally when the data is finished being sent, wire.end transmission to stop communication to the slave. Button 1 and button 2 are stored as variables to be easily used in code. Then there are 2 bytes, with the first byte being an array with the pin numbers as the elements. Then the second byte being an integer that gets set to 0 or 1 that sets the LED state. In the setup, the 2 buttons get set up to read if they are pushed. Then a wire.begin to start the I2C communication between the devices. The master Arduino continuously checks if a button is pressed. If so, then a counter variable is set and gets passed to a switch statement. Case 0 turns off the LED and then has a slight delay. Case 1 sets the state to be 1. This will be the digital write state, which in this case is 1, and will write high to the LED. Then the master begins transmission and sends the first byte of data, which is the element 1 in an array of ints that are the pin numbers. The master then sends the state that the LED should be written as an integer form, then after a short delay repeats with the next pin array element. This repeats until all are on, and then does the same thing, but instead turns the LEDs off. Case 2 mirrors the previous case, but starts right and goes left. It does this by starting at the pin array element 4 and going down. Then for the slave, the LED pins are set up for output, and wire.begin is called. Then a wire.onReceive is set up to a function called receiveEvent that sets out a pinout variable with the pin number the master sent, and a state variable with the number the master sent. Then with the specified number, pin, and state, it then digital writes to the LED with the new state. The modules that use an I2C connection are the GY521. The master Arduino would send the information to the GY521 using the SCL and SDA ports. The other module that uses I2C is the real-time clock module. I was able to get a hardware implementation working that outputs to the serial monitor the date and time. This implementation works by using the DS3231 library and creating a clock object and an RTC datetime variable. Then initializing the clock and using the clock.setDateTime function and setting the current date and time of compilation. Then in the loop, the datetime variable gets the datetime from a clock.getDateTime function. It then prints to the serial monitor the values for the year, month, day, hour, minute, and even second. Here are the functions for the getDateTime and setDateTime functions used in the code.